All right, dilation. Now, dilation is like the word dilate. When your eyes get dilated, anybody ever been to the eye doctor and have your eyes dilated? What happens when they dilate your eyes? What'd you say, CJ? They get bigger. Your what gets bigger? Your pupils get bigger. They get bigger so they let more light in so the doctors can see inside of your eye better. Okay? So it makes your pupils bigger. Do they change the shape of them? No. Your pupils are still round. It just changes the size. Okay? Just changes the size of them. So, when a dilation happens, it makes something bigger or smaller. The center dilation is where it gets bigger or smaller from. Now, when the center, if you're working with a graph and the center is the origin, it's easy. You just multiply numbers. Okay? When the center of dilation is some other point that's not 0, 0, then you have to do a little more math. Okay? But when the center is 0, 0, you just multiply. And the number you're multiplying by is called the scale factor. That's how much bigger or smaller it is. So if your scale factor is 1/2, the new figure is half the size of the old figure. If your scale factor is 3, the new figure is 3 times larger than the old figure. So if you have an enlargement, your scale factor is bigger than 1. And if it's between 0 and 1, so if it's a fraction or a decimal, like 0.75, it's a reduction. Okay? Now, the ratio method is just, okay, they say ABC was going to be dilated with a scale factor of 1/2. ABC is out here. What they do is from the center of dilation, they go halfway back to P. And put a B, halfway, put an A, and halfway put a C. And then that figure is going to be half as small. Okay? You won't have to do anything quite like that. Most of our things will be on graphs, or you'll be able to look at it and they'll have a measurement on there. Okay? They also have what's called the parallel method, where each of the sides are parallel. And this one had a scale factor of 2. So the new figure is going to be larger. And then if you go parallel twice as far away from the center of origin, okay, it makes an object twice as large. Okay? So half the size is smaller, a reduction. Twice the size is bigger, an enlargement. Okay? So a dilation. Now, the scale factor will be the first thing given. And if they do not give a center of dilation, the center of dilation will be 0, 0. But then they'll also give a center of dilation if the center is not 0, 0. So an enlargement is when the scale factor is bigger than 1. A reduction is if it's between 0 and 1. So here's an example. Okay? We have a dilation. Now, the red one is the new one. Okay? So is the red one an enlargement or a reduction? Enlargement. Now, how far is it from A to D here? 2. How far is it from A prime to D prime here? 6. Okay, so to figure out the scale factor is new over original. The scale factor is always the new over the original. The new was 6. The original was 2. So what's our scale factor? 3. Everything's 3 times larger. So if this side is 3, what should this side be? What's 3 times 3? 9. So if this side is 3, this side is 9, and so on. Everything is 3 times as far away from A or from P. So A was 2 away, so A prime is 6 away. D was 4 away, D prime is 12 away, and so on. Okay? What do you think the scale factor is for this one? Now, again, the red one's a new one. So what's the red one's measurement that you see? 18. What's the black one's corresponding measurement? 12. 18 over 12 is 3 over 2 or 1.5. So either one of these work for the scale factor, 3 over 2 or 1.5. Okay. All right. So this says D3 triangle ABC. So it says dilate it and the scale factor is 3. Does it give a center of dilation? Nope, it doesn't give a center of dilation. So where's our center of dilation going to be from? 0, 0, the origin. So right now, A is at 2, -1. A prime will be 3 times each of those numbers. What's 3 times 2? 6. And 3 times -1? Okay. B right now is at -1, 2. B prime will be where? -3, +6. And C right now is at 3, 0. C prime will be at 9, 0. Okay? So the new one will be there for C prime at 9, 0. A prime will be down here at 6, -3. That's a little bit too much. 6, -3 is about right there. And back 3 up 6, somewhere about right there. So the new one will look like that. Okay? Now you say, well, why didn't it surround it? Well, we're dilating it from right here, from the origin. So it passes through each mark and goes 3 times further. Okay? So if you know how to do this, okay, you're on the right track. D of 6. So if we have W, X, Y, and Z. W right now is 2, -2. X right now is -4, 2. Y right now is 0, 4. And Z is at 4, 2. So if we go on D6, dilating it by a factor of 6, what will W be, Maxon? W prime. 12, -12. What would X prime be, Ray? -24, 12. What would Y prime be, Emily? 0, 24. What would Z prime be, Lane? 24 and 12. Okay? All right, this one, the center of dilation is not 0, 0. The center of dilation is R, so everything moves from R. Okay? So R, everything's half the size. So R will not move because that's the center of dilation. So R is not going to move. Okay? But all the other things move. So how they did it is they figured out how far it moves vertically or how long they are vertically or horizontally. They multiplied that number by 1/2. 6 times 1/2 is 3. -8 times 1/2 is -4. And then moved that by that amount, horizontally or vertically. Move that by 3 or -4. So RS is 1, 2, 3, 4, 5, 6 long. Okay? So to find the new S, you go half of 6, which is 3. So the new S would be right here, 3 away, because R doesn't move, because everything moving from R. So the new S would be there. Okay, Q is 8 down. So what's half of 8? 4. So you go 4 down from R. The new Q is right here. And common sense would be, okay, we're making a rectangle. So the new T would be right there. So there's a reduction of 1/2. Okay, which is what they got there. Now, we're going to look at something else here. We're going to look at the areas of this. Okay. How do you find the area of a rectangle? Length times width, base times height, however you want to say it. What's 6 times 8? 48. The new one is 3 by 4. What's 3 by 4? 12. What's 12 over 48? 1/4. The scale factor was 1/2. The ratio of the areas was 1/4. So is the scale factor the same as the ratio of the areas? No, it's not. Okay. Let's look at the perimeters once. How do you find the perimeter? Add up all the sides. Okay. So RSTQ is 6 plus 8 plus 6 plus 8, which is what? What's 6 plus 8 plus 6 plus 8? 28. Very good. R prime, S prime, T prime, Q prime is 3 plus 4 plus 3 plus 4. What's 3 plus 4 plus 3 plus 4? 14. What's the ratio of the perimeters? 1/2. The ratio of the perimeters is the same as a scale factor. The ratio of areas is not. It's something special. So let's look at one more ratio of areas here. Okay, let's say we have a box that's 5 by 8, and then a box that's 15 by 24. What's the scale fact? What happened from here to here? It's 3 times bigger, so the scale factor is 3 times. Okay? So, what's the area of this one? What's 5 times 8? 40. You might need a calculator for this one. What's the area of this one? 24 by 15. 360. Okay? Now, let's look at the ratio of the areas. This one's a new one. So 360 over the original one, 40. What's 360 divided by 40? 9. So we have a scale factor of 3, which leads to a ratio of areas of 9. So how is the ratio of areas related to the scale factor? You square the scale factor, right? Okay, so let's go back up to this one. If the scale factor is 1/2 and the ratio of areas is 1/4, what happened to the scale factor? We squared it. Okay, so to find the ratio of the areas, it's the square of the scale factor. Okay, let's look at the perimeters of this one. What's the perimeter of this one? What's 5 plus 8 plus 5 plus 8? 26. What's 15 plus 24 plus 15 plus 24? 78. How are 26 and 78 related? What's 78 over 26? 3. So how's the scale factor and the ratio of perimeters related? The scale factor and the ratio of perimeters are both 3. They're both the same. So the ratio of the perimeters is always the same as the scale factor. The ratio of the areas is the square of the scale factor. All right. Blueprint for the new library uses a scale factor of 1 to 50. Okay. Mr. Ayers measures the reading space on the blueprint to find the dimensions so he can order the furniture. What's the dimensions? Now, this is in centimeters. On the drawing, it is 14 centimeters by 12 centimeters. Okay? How much is the actual space? What's the size of the actual space? Well, how many times bigger will it be if the scale drawing is 1/50th of the actual room? How many times bigger is the actual room? 50 times bigger. So you take each of these times 50. What's 14 times 50? 700 centimeters. What's 12 times 50? 600 centimeters, which if we change them to meters is 7 meters by 6 meters. If we think of a meter is about the same as a yard, that would be 7 yards by 6 yards, or 21 feet by 12 feet. Or not 12, 21 feet by 18 feet, which is a decent sized room. Okay. Okay, here's an apartment. Okay. Each of these grid squares is 1/4 of an inch. Okay. What's the dimensions of his apartment? Well, the apartment's how many times bigger than this? 96 times bigger. Okay, it's 96 times bigger. So if we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times 1/4 of an inch. What's 14 times 1/4? As a decimal. What do we get? 3.5 inches. And this is 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 1/4 is 2 inches, correct? So if it's 96 times bigger, take 96 times 3.5 and 96 times 2. I know 96 times 2 is 192 inches. Somebody, 96 times 3.5. 400 and what? 336? Now, that's hard to think about in terms of inches, okay? We think of a room in terms of feet. So how would I change 336 inches to feet? Divide by 12. Somebody, divide this by 12. How many? 28 feet. 192 divided by 12. 28 feet by 16 feet. Okay, that's the size of the apartment. All right, so a dilation makes something bigger or smaller. If the scale factor is bigger than 1, it's an enlargement. If the scale factor is smaller than 1, it's a reduction. Okay? And then when we talk about areas, okay, If this is 3 inches and this is 9 inches, what is my scale factor here? 3. Let's say the area of this box is 15 inches squared. What would the area of this one be? Well, if the scale factor is 3, what's the ratio of areas going to be? Not 3, but 9. You square the scale factor. So this is 9 times bigger. So if the area of this one is 15, what's 9 times 15? 100 and what? 45? 35. Thank you. 135 square inches. Okay? So you'll hit a couple ratio of areas problems that you just kind of need to figure out as you go. All right. So today we're starting nice and slow, just one section today. We'll have a quiz next time over a few problems from it. So you'll have to be ready for a short little 4-problem quiz next time, and then we'll do similarity ratios next time. So those of you who had me last semester, you don't have to log into Savvis Realize anymore. You can just go to your Google Classroom and get to Savvis from there.